Hi, and welcome back to Microeconomics. In this unit, we're talking about comparative advantage and production. And what we're going to do in this video is be talking about thinking about opportunity cost and comparative advantage. So this is really the heart of this unit. We're going to be getting into the meat of things here in thinking about these trade-offs. We're applying that model that we introduced previously, the production possibilities frontier, and we're using that not just with one producer, but extending it to look at two and thinking about what that means in terms of production, comparative advantage, and trade. So we're going to have two producers, as I mentioned, and the example that I'll be using in this portion of this video is an example using Bert and Ernie, and they're going to be making two goods. They're going to be making duckies and sweaters. And our production times, one of the three ways that we talked about representing production, are going to be Bert can make a rubber ducky in 20 minutes. It takes Ernie 30 minutes. In terms of sweaters, Bert can make a sweater in 12 minutes, and it takes Ernie 60 minutes. So we can see from what we have introduced before that Bert has what's known as an absolute advantage in both ducky production and sweater production, meaning that he can produce them faster. Another way of representing these is to think about how much he can make with a given unit of resources. Now, the resource that we're going to be focusing here is their time. Their hourly output is the way we're going to represent that. So in 1 hour, Bert can make either 2.5 duckies or 5 sweaters. On the other hand, Ernie can make 2 duckies or 1 sweater. When we're thinking about comparative advantage, this is what's going to drive specialization. And I think the easiest way to think about comparative advantage is to look at this hourly output view, because it's showing them in sort of a easily compared input. This is how much you can make with the same input, 1 hour of labor. And the first question we're going to ask is who has the comparative advantage in duckies and who has a comparative advantage in sweaters? Now, to think about comparative advantage, we need to introduce this idea of opportunity cost. So let's first look at individual graphs. We learned in our previous video how to graph individual production possibilities frontiers. So we can take this hourly output and say what are the maximum amount we could do. Let's say we have 8 hours. So for Bert, the maximum sweaters he could do is we take 5 sweaters times that by his 8 hours. He could make a max of 40 sweaters if he was using all his time on sweater production. If he used all his time on ducky production, it's 2.5 per hour. 8 hours would mean 20 duckies produced. And because in our simplified model, there's a linear relationship, a linear trade-off between the two, or constant trade-off between the two, his possibilities is simply the straight line between those two extremes. Now, I'm also emphasizing the slope of that line, which is the rise, which is the fall moving from sweaters to duckies, of 40 over 20, or a slope of -2 over 1. For Bert, that was Bert. For Ernie, the maximum amount of sweaters he can make is only 8, because he's only making 1 sweater per hour. The maximum number of duckies he can make is 16, and his slope is -1/2. We could also show this on one graph where they're put together. When we're thinking about opportunity cost, we're thinking about what Bert gives up. So first we'll focus on Bert, and then we'll focus on Ernie. So in 1 hour, Bert has the option of either making 2.5 duckies or 5 sweaters. So in order to do those 2.5 duckies, each hour he has to give up 5 sweaters. So his opportunity cost of a ducky is 5 sweaters divided by those 2.5 duckies. In other words, he's giving up 2 sweaters per ducky. And this connects back to the slope of that production possibilities. It's actually 2 for 1 because it's 2 sweaters to get 1 ducky. Now, looking at the opportunity cost for Bert in terms of the other way around, to make 5 sweaters, he needs to give up 2.5 duckies, moving the other way. So the opportunity cost of a sweater is 2.5 duckies over 5 sweaters, or 0.5 duckies per sweater. And we've filled in this opportunity cost. And again, I'm emphasizing units here. Units will really help you keep straight what you're supposed to use in what context. They really can be your friend when things can get confusing in terms of which version to use. For Ernie, in 1 hour, he has the option of either doing 2 duckies or 1 sweater. To do the 2 duckies, he's giving up 1 sweater. Therefore, for Ernie, the opportunity cost of a ducky is 1 sweater per 2 duckies, or 0.5 sweaters. And this connects to the slope of Ernie's PPF, which is -1/2. Those two concepts are connected because what we're doing as we move on both of these from left to right is we're giving up some sweaters to get some more duckies. Giving up sweaters to get some more duckies. And so what we have with Ernie's opportunity cost for those duckies is 1/2 of a sweater. The opportunity cost for sweaters, right, is how many you're getting over how many you're giving up. And so in general, the opportunity cost is connected to this absolute value of slope in this particular way. It shows what we're giving up versus what we're getting. And opportunity cost is always what you're giving up divided by what you're getting. Now, opportunity cost is connected to comparative advantage. They're intertwined. Comparative advantage is defined as having lower opportunity cost. And I want to emphasize again, it is measured in units of the other good. And so if we're thinking about what's the opportunity cost of sweaters, the question is what we're giving up. Well, we're giving up duckies, and so it's measured in duckies. The opportunity cost of one is measured in the other. Right? See, we have sweaters here and duckies here. When we're thinking about comparative advantage, the question is who's giving up less? Right? And what we have to look at is who has the smaller opportunity cost. For sweaters, Bert has the lower opportunity cost for sweaters. He's only giving up 1/2 a ducky there. And therefore, we say that Bert has lower opportunity cost in sweaters, or the comparative advantage in sweaters. Right? He is giving up less. It's 0.5 versus 2. Ernie has lower opportunity cost in sweaters. He is giving up, in duckies. He is giving up 0.5 sweaters versus the 2 sweaters that Bert gives up. And I want to emphasize that Ernie has the comparative advantage here in duckies, but he does not have the absolute advantage. Bert can make more of either. He is just a faster worker. He, for whatever reason, can make more duckies and more sweaters. Right? That's what absolute advantage is about. Right? Who can make more in a given amount of time? And we can see that both in terms of his hourly output and his production time, the fact that he is faster. Having absolute advantage does not mean that you'll have comparative advantage, because comparative advantage is about what production you are giving up. And as this chart shows, Ernie gives up less compared to Bert in terms of producing duckies. This brings up the question then, is it possible, we saw that in this case it was one had comparative advantage in one good, the other had the comparative advantage in the other. And the question might be, is it possible to have comparative advantage in both? So let's take a second to quickly think about that. In short, the answer is going to be no. This isn't just the fact that it happened to be in this particular case that each of them had that comparative advantage in one good. This is actually generally the case. in our two-good model, the opportunity costs are always going to be reciprocal of each other. So if you think about it graphically, as we move from one good to the other, the opportunity cost is how much you're giving up for how much you're getting, right? Or the slope, right? That's the opportunity cost to get duckies. And the opportunity cost moving the other way is the reciprocal of that, right? And so the fact that these opportunity costs, when we put them in a table here, were the reciprocals of each other, was not something that will happen to happen. It's the way that these things are defined. You're giving up one to get the other, and moving the other way, you're giving up the same amount, or the reciprocal amount. What you're getting switches to what you're giving, and vice versa. Right. So whenever we have two goods, if the opportunity cost for a particular person A is greater than the other person B, then because the reciprocals flip that inequality, it must be the case that the opportunity cost for person B is greater than person A for the second good. It is possible, in theory, that the opportunity cost is the same for all of those goods. In this case, we wouldn't really say that anyone had the comparative advantage in that case. So this is one method that we use to think about opportunity cost and comparative advantage. It's going to help us to think about trade-offs. It's going to help us think about production. And it's a helpful way to represent those trade-offs. What we're going to do next is think about combining production, how comparative advantage helps us think about working together efficiently. And that's what I will be covering in our next video. So thank you for joining me, and let me know if you have any questions. Take care.